Hello student, let's try to understand concept of equilibrium. Okay, so that is what brief we are going to discuss student, concept of equilibrium. Consider the general reversible reaction student, A plus B reversible C plus D. In the beginning at time t equal to 0, the concentration of E and B are maximum and the concentration of C and D are minimum equal to 0 because C, D are not yet formed. So here you see student, this is the C and D. This line is going to be C, D and this is going to be A plus B. H, the reaction proceed, the concentration of A, B are decreasing. So it is the decreasing student slowly. With the passing of time where the concentration of C, D are increasing. So this is concentration are going to be increased student. Therefore, the rate of forward reaction is decreasing while the rate of backward reaction goes on increasing. Ultimately, a stage comes when the rate of forward reaction become equal to rate of backward reaction. So this is the line when the forward and backward reaction become equal. The reaction is said to be the state of equilibrium. This state is what is called student equilibrium. Next one. The variation of reaction rate with time, ultimately the attainment of chemical equilibrium, may be represented diagrammatically as shown figure 7.6. So here is this is the forward reaction going, this is the backward reaction is going. At one time this become equal. That is what student, that is the state of equilibrium. This line is explaining. The following example is to illustrate the how the equilibrium attain. Okay, decomposition of calcium carbonate in closed vessels. If calcium carbonate is heated in closed vessel, the reaction is reversible, CaCO3 CaO plus CO2. If the temperature of the furnace is kept constant, say 1073 kilojoule Kelvin, not kilojoule, Kelvin, then what is happening, and the vessel is connected to a manometer. The pressure due to CO2 gas keep on increasing and ultimately become constant. This is obviously due to the fact that now as much of CO2 is formed from CaCO3, the same amount of CO2 reacts with CaO to give back CaCO3. In other words, the rate of forward reaction and backward reaction have become equal. Hence the reaction attain equilibrium. This is the furnace student in which the CaCO3 is heated. Then this is the too much of the gas is liberating. This is the vacuum. So this is the initial state student where only CaCO3 are there, manometers are there. Now equilibrium state, this is the reaction. Now you can see CaCO3 giving CaO plus CO2. Now the pressure has rises up to here. Earlier this is here. But this pressure is not going more because the amount of CaCO3 what CO2 produce, that is combining and going backward. So this is what the condition is, what state of equilibrium. Next one, decomposition of N2O4 in a closed vessel. The decomposition of N2O4 in closed vessel is a reversible reaction. N2O4 is almost stable at 0 degrees Celsius and is almost colorless. Thus, if N2O4 is taken in glass bulb, which is then sealed and placed in ice, it is almost colorless. Now, if the sealed glass bulb is shifted into the vessel containing water at 25 degrees Celsius, the bulb start acquiring brown color, which first depends and then become constant. This indicates a state of equilibrium in which concentration of N2O4 and NO2 have become constant. That both are present in the reaction mixture can be tested by increasing the temperature of the bulb further when brown color depends, indicating more dissociation of N2O4, and by cooling the bulb now down from 25 degrees Celsius when the brown color fades, indicating combination of NO2 molecule to form N2O4. So it is colorless. This is reddish brown color. After certain time it become only showing that is the brown color is going to fade. It is saying that is it is the equilibrium is established, student. Thank you so much for watching, student.